We'll continue our lecture, lecture 23, on the topics of wave propagation. So allow me to recap the topics that we have learned in our last class on Thursday. So in our class last Thursday, we did started the lecture on this topic of wave propagation. Basically, we have learned about the behavior of wave propagated in this particular material, the free space and also the loss dielectric. So basically, the objective for lecture 23 that we have learned, in which we have learned the behavior of propagation in a free space, free space and lossless medium, and we have investigated the behavior of the wave, which include the wave equations, the wave velocities, the phase constant, and also relationship between the propagating electric field and magnetic field. Okay, allow me to summarize the topics that we have learned basically. So during the lectures on the lecture on Thursday, we did learn that there are four equations of Maxwell. If we can write it here, we have divergence of D equals to rho V. Then we have divergence of B equals to 0. We also have the curl of E equals to negative dB over dt. And finally we have the curl of H equals to J plus dd over dt. Okay, so these are the four equations of Maxwell that we have discovered based on our previous lectures. And in formulating the wave equation, what we did is that we are assuming that there are no source of field in which we have the rho v equals to 0 and j equals to 0 for these four equations. And as such, the equations have been reduced to only divergence of D equals to 0, divergence of B equals to 0, curl of E equals to negative dB over the dt. Then also we have finally the curl of H equals to dd over the dt. Okay, so these are the equations that we have simplified based on the assumptions that the wave that we are formulating are free from the source of field. And from these four equations, we have formulated the wave equations. So I don't think I don't have to repeat the procedures, but we just summarize it, in which end up we managed to get the equation in which we assume that the wave is said to be propagated. If I can just write it here, the direction of wave is towards positive z direction. Okay, and then we have the E field is said to be polarized along x direction. We have H field is said to be polarized along y direction. So these are the assumptions that we made when we formulated the equations. Okay, and from these assumptions that we made, we have agreed that basically the E field can be written as Ex of exponential negative j of kz, or k naught of z if we consider a free space environment, k naught of z, whereby k naught is your free space propagation constant or the phase constant. And also we have Ex exponential positive j k naught of z. Okay, so this is the equations that we managed to get from the wave equations. And we have agreed that this is the wave that is said to be propagating in the positive z direction, while this is the wave that is said to be propagating in negative z direction. So this is a written wave, a written wave. So what we did is that we can then write these equations in terms of the trigonometric terms, and we ignore the imaginary terms of your exponential terms. So we can get that the E field basically can be written as Ex of a cosine of omega t minus k naught of z, okay, the direction of x. And also we have plus Ex of cosine omega t plus k naught of z in the x direction, okay, in which this is the okay, basically this is your This is your electric field that is said to be propagating in the positive z direction, and this is the field, the E field that is propagating in the negative z direction. Okay, and from here we have then formulated the relationship between the E field and the H field. But before that, if I can go back to this, we have agreed that the direction basically is given by the cross product between the E field wave and the H field wave, in which the direction should be given by the polarization direction of the E field cross the polarization of the H field. Yeah, so that's why that's how we can get the direction, or that's how we can obtain the polarization of your E field and the H field is if one of these is given. Yeah. Okay, so hopefully you can then clearly understand the relationship between the direction of the wave with the polarization of the E field and also the polarization direction of your H field. Yeah, so this is the relationship. Okay, and subsequently from this E field equation, we can then formulate the H field equation, in which the H field, if we have assumed just now from this assumption that if the E field is in the x direction, so basically the H field should be in the y direction, in which your H field equation should be H of y cosine omega t minus k naught of z direction of y plus hy cosine omega t plus k naught of z direction of y. Okay, so in which from here we can find relationship between the amplitude of the E field and the H field, this relationship in which we can say that the ratio between the amplitude, the Ex and the Hy shall be given by the intrinsic impedance value, which is the eta, and the formulation for this will be equals to set of mu naught divided by epsilon naught. This is for the case of free space medium. And for the case of lossless dielectric, yeah, we are supposed to get the eta, yeah, will be set of mu over epsilon, which will be set of mu naught mu r divided by epsilon naught epsilon r. Okay, so that these are the difference, yeah, between the impedance for the case of free space, yeah, this is for the case of free space, and this is the impedance of the medium. In case this is the impedance for the lossless dielectric, which should be based on this equation. Yeah. So by now, I hope that you can now distinguish the behavior of the wave propagation in a free space and also in a lossless dielectric. And also we have agreed that the phase constant, k naught, for the case of free space shall be equals to omega set of mu naught epsilon naught. Okay, omega is the radial frequency, yeah, and then from here we can also write that the velocity of the wave in a free space medium, which is a c, shall be equals to 1 over set of mu naught epsilon naught, in which basically this k naught can also be written as omega divided by c. Okay, and for the case of a lossless dielectric, we can also write that the phase constant k will be omega set of mu epsilon, yeah, which will be omega set of mu naught mu r epsilon naught epsilon r, in which the velocity of the wave in a lossless dielectric will be equals to 1 over set of mu epsilon. About the same equation, the difference is that for the free space, we have mu naught epsilon naught, but for the lossless medium, it is mu epsilon. And this will be 1 over set of mu naught mu r epsilon naught epsilon r. Yeah. So this is the equation for the wave velocity in a lossless dielectric as compared to the equation for the wave velocity in a free space medium. Okay, so for the free space medium, the velocity will be common to you, which is 3 times 10 power of 8 meter per second. But for the case of the velocity of wave in a lossless dielectric, it will be highly depending on the mu r and also on the epsilon r, yeah, relative permittivity and relative permeability. So in general, these are the things that we have learned in our lecture last Thursday, and I hope by this summary of the topics that we have learned, I hope that you can you can grab the concept, yeah, of the wave propagation in the medium of free space and also in the lossless dielectrics. Okay, is there any questions before I proceed with the examples? No, yeah? Okay, if there's no question, I think we can now proceed with the examples, because last class we did cover the first examples only, so we're going to proceed with the rest of the examples related to the wave propagation in a free space and lossless medium. Okay, I think we did this example in our class last Thursday. So we proceed with this example here, which is a sample of final exam questions. Okay, in this particular examples, we are given a plane wave of frequency 200 kilohertz with a peak amplitude of 20 volt per meter is said to be propagated inside a lossless dielectric. Okay, so this is the case of wave propagation in loss dielectric, having the following properties, given that the relative permittivity is 2, whereas the relative permeability is equal to 3. So based on these informations given, you need to obtain the wave velocity, yeah? So I think this is a very straightforward questions. So we know that in a loss dielectric, the velocity should be given by 1 over Z of mu epsilon, which is 1 over Z of mu naught mu r, epsilon naught epsilon r. Okay, this is very straightforward. So we're going to have 1 over Z of 3 for the mu r and 2 for the epsilon r, and we just multiply with 3 times 10 power of 8. Yeah, because we have learned that for 1 over Z of mu naught epsilon r, sorry, mu naught epsilon naught. Yeah, we have learned that if we have mu naught epsilon naught, so this is 3 times 10 power of 8. Yeah, so we just multiply the value of 1 over Z of mu r epsilon r with the speed of light, which is 3 times 10 power of 8. So I left this for you to solve this. So the answer should be speed, which is in meter, sorry, velocity, which is in meter per second. Yeah. Okay, so I hope it's clear. Very straightforward questions. Whereas number 2 is to find the intrinsic impedance of the dielectric. Also, this is very quite straightforward. The impedance of dielectric basically should be given by the symbol, the eta, and we have learned that the intrinsic impedance for the loss of dielectric should be based on the equation of mu divided by epsilon naught. Sorry, mu divided by epsilon. Wait for that. Okay. Epsilon, yeah? Okay, so we have this epsilon, and basically this should be based on sort of mu r mu naught over epsilon naught epsilon r, and basically it should be equals to set of mu r over epsilon r multiplied with 377 ohm. Yeah, because the set of mu naught over epsilon naught, which is the impedance, the intrinsic impedance for the free space medium, should be 377 ohm. Yeah, so just multiply with 377, so that should be set of 3 divided by 2 multiplied with 377, and that should give us the impedance of dielectric in the units of ohm. Yeah, okay, very straightforward. And then for the third question, which is to find the phase constant of the propagated wave, which is to find the k, yeah, the k. So the k, we have learned that it should be based on the equations of omega set of mu epsilon. Okay, that should be the phase constant. Okay, so the phase constant and the propagation constant are the same parameter. Yeah, it's the same thing. So we're going to have it as omega divided by v. So v is velocity that we have obtained from part 1. Okay, so I just put it, this is from part 1. We have obtained it from part 1 of this example. And the omega basically should be the frequency in radian, which is 2 pi, which is a radian frequency, sorry, yeah, a radian frequency. So it is 2 pi multiplied with the frequency, which is 200 kilohertz, so 200 times 10 power of 3, yeah, in radian radian per second. Yeah, so we're going to have 2 pi of these frequencies, and we're going to have the velocity that you can substitute it from part 1. Yeah, so that should be your k, which is in the units of radian per meter unit. Yeah, so please calculate this for me. Just simply find a ratio between the frequency and also the velocity of the wave. Okay, any question for this example number 1? Okay, no questions. I proceed with the example number 2. Again, this is basically related to the previous uh, final exam questions. Yeah. So again, if we base on the questions here, it is given about the magnetic field. Yeah, magnetic field component of a plane wave in a lossless dielectric. Yeah, lossless dielectric, and the magnetic field a wave is given by 30 sine of 2 pi times 10 to the power 8t minus 5x in the z direction. Okay, so based on these equations, it is good if we can extract important informations, yeah, from this wave equation, in which if we base on this equation, the first thing that we have to understand is what is the direction of the wave. Okay, so direction of the wave should be in the x direction. Yeah, should be in the x direction. So that should be the direction of your wave, which is in the x direction. I just put it x direction. And the H field polarization. Yeah, polarization of H field. If you base on the equation here, it is in the z direction. So we just put it as a z direction. Okay, so I hope that you can understand these extraction of the information. Yeah, it's very important. Yeah. Okay, and from these equations also we can obtain that the omega of the wave is this value, which is 2 pi times 10 to the power 8. Okay, and then the magnitude of the wave, if I just put it as h magnitude here, is equals to 30. Yeah, it's equals to 30. Okay, so this is 30 milliampere per meter. Yeah, in milliampere unit. Yeah, milliampere per meter unit. So this is the amplitude for the H field. Yeah. And based on this, the first questions that you need to be obtained is you need to find out what is your relative permittivity. Yeah, relative permittivity. Okay, so how to calculate the relative permittivity for these particular questions then? Okay, so basically, from these equations of H, we can also say that the phase constant, yeah, the phase constant or the K for the wave is equals to 5, yeah, equals to 5 based on this equation here. Okay, this is your K, which is the phase constant, so that should be equals to 5. And we know that the K is given by the equations of omega sud of mu epsilon, which is equals to 5. And from this, we can write it as 2 pi times 10 to the power 8, which is for the omega, and square root of mu. And in these questions, we are not given any value for the mu r. So we assume that mu r equals to 1. Yeah, relative permeability of the medium is equals to 1. That is our assumption. Yeah, because we're not given any value of the mu r. So we just put it as 1 as the mu r value. And then mu naught, which is 4 pi times 10 to the power negative 7. That's for the mu naught. And the epsilon will be the epsilon naught, which is 8.854 times 10 to the power negative 12. And then multiply with epsilon r. And then this should be then equals to 5. Yeah? Equals to 5. Okay, your task is then to calculate what should be the value for the epsilon r. Okay, so if we proceed with the calculation of this value, yeah, so basically, let us calculate the value. Yeah, so we have 2 pi. So if you have a calculator, please calculate this for me then. Just help me on calculating this value. Okay, so that should be 2 pi. Okay, sorry for this. Yeah, I need to use the Okay, I need to use the online calculator, which is easier for me then. So we have 2 pi, okay, times, sorry, this should be 10 power of 8, yeah? Okay, 10 power of 8, okay, and then this need to be multiplied with the square root of your values of mu naught, which is 4 times pi times 10 power of negative 7. Okay, that's for the mu naught. Okay, and then, sorry, and then multiply this with your, sorry for this, multiply with the, what you call that, the epsilon naught, which is 8.854, okay, times 10 power of negative 12. Okay, so that will give us the value for these particular equations. So that basically will be equals to 2.095, yeah, 2.095. Okay, so let's go back to this slide. Okay, so basically we should have that. Okay, so we're going to have 2.095. Okay, multiply with sorry, we're going to have set of epsilon r shall be equals to 5 basically. Okay, and from here we can write that epsilon r shall be equals to 5 divided by 2.095 squared. Yeah, so that should be your epsilon r. Yeah, so this is what based on what we have calculated using the online calculator just now. So basically from here, if I can use my calculator here, 5 divided by 2.095 square. So that should be equals to 5.69. Yeah? So that should be the value of your free space. Sorry, for the purpose relative permittivity for this lossless dielectric. Yeah. So that should be your value for epsilon r, which is 5.69. Yeah, for this particular lossless medium. Yeah. So hopefully you understand how to calculate the value of epsilon r. Basically, this is to be based on the informations of the K given in the questions. Okay, number 2, calculate the wavelength and also the wave velocity. Okay, for the wavelength, I think it should be straightforward because we are given the omega. Yeah, we are given the omega. And from the omega, we can find the frequency, which is 10 power of 8. So the F is equal to 10 power of 8 hertz. And from here, we can find the equations of the V should be equals to F lambda. And the lambda shall be equals to V over F. Yeah, so V is the velocity that need to be obtained first. Yeah, and the velocity should be equals to 1 over third of epsilon naught, sorry, epsilon r, and also the mu r multiply with 3 times 10 power of 8. Okay, and if you base on this, we can write it as 3 times 10 power of 8, sorry, yeah, and divided by third of 5.69. Okay, and the value for that will be about 1.25. Yeah, this is 1.25 times 10 power of 8 meter per second. This is the equations. Yeah, because the velocity based on this equation, we have assumed that mu r equals to 1, and the epsilon r is based on what we've obtained in part 1 just now, which is 5.69. So we just substitute this in the equation here, and end up we can find the v, the velocity, this value. Yeah, and from here we can just obtain that the v will be 1.25 times 10 power of 8, and the frequency will be 10 power of 8, and end up from here we can cancel out this 10 power of 8, and we're going to have it as 1.25. Yeah, 1.25. Yeah, and that should be in the units of meter. Yeah. Yeah, let me see. So this F is in meter, meter per second, I believe it's meter per seconds. Sorry, this is per second, sorry, per second, and this is 1.25 meter per second. So the velocity, the lambda is in meter, 1.25 in meter unit. Okay, so that should be your lambda, yeah, the wavelength and the velocity. Okay, so that's how we calculate the velocity, yeah, and the velocity that we obtain shall be then used to calculate the lambda or the wavelength of the wave. Yeah. Okay, any questions for part 1 and part 2 so far? I hope it's clear, yeah? Okay, number 3 is to determine the wave impedance. So the wave impedance basically shall be based on the equations of eta. Okay, wave impedance shall be equals to the surd of mu r, mu naught over epsilon r, epsilon naught. Okay, and that should be based on surd of mu r over epsilon r multiplied with 377. So we have agreed just now that the mu r equals to 1, epsilon r equals to 5.69 that we have calculated. Okay, and that should be our uh, permittivity, sorry, impedance, yeah. And for this, we can get it as equals to, uh, let me see. So the answer for that will be equals to 158 ohm. Yeah, that should be your impedance, yeah, the wave impedance. Okay, right. I think 1, 2, 3, and it's done already, or having calculated. And then for part 4 is to determine the polarization of the wave. I think that should be straightforward. If you based on this equation of H field, the wave is to be polarized in the Z direction. So this should be in the Z direction. Okay, in Z direction for the wave polarization. Okay, number 5 is to find the corresponding electric field component. Yeah. So that is also straightforward because we have agreed that the E field should be having about the same terms of the equation here. The difference will be on two things. The first one is on the amplitude, and secondly is on the polarization of the wave. Yeah. Okay. So we know that the wave direction is x, and the direction is equals to the cross product between the polarization of the E field and the polarization for the H field. Okay, and we know that the H field polarization is towards Z. And basically from here, we shall then obtain that the E field is said to be polarized along Y direction. Yeah, so that should be the polarization direction for the Y. Yeah, and for the H field, I mean for the amplitude of the E field, okay, we can write that the E field basically shall be equals to uh, H field amplitude, which is 30, multiply with the impedance value, which is 158, sine of 2 pi times 10 power of 8t minus 5x, and the direction of the polarization direction for the E field should be in the Y direction, yeah, in millivolt per meter. Okay, how can we get this as the amplitude? Okay, so you have to go back to the basic equation that relate both the amplitude of the H and the E, whereby is given by the ratio between the E field amplitude and the H field amplitude shall be based on the impedance value. And from here, we can find that the amplitude of the E field shall be equals to the H field amplitude multiplied with the impedance. And from this relationship, then only we can have it as 30, which is the amplitude of the H field, and the impedance value, which is 158. So that should be the amplitude of the E field, and that's how we obtain it to be this value. Okay, so the rest are the same. Sine omega is the same, beta should be the same, and the difference will be only on the polarization direction of the E field. Okay, so number 5, I mean the E field component, the E field wave equation should be this one. Yeah. Okay, any question for this? Okay, hopefully it's clear, yeah? And finally, which is to find the displacement current density. Okay, this is also quite straightforward, which is to find the JD. Yeah, the JD. So the JD is to be based on what we have learned in lecture 22 previously on displacement current concept. Okay, and we have agreed that your JD shall be based on the equation of dd over the dt, right? This is the equation for displacement current density, and we can rewrite this as epsilon dE over the dt or we can also rewrite it as a 5.69, which is the epsilon r multiplied with epsilon naught. Yeah, and the dE over dt will be d over dt of the E field that we have calculated from part 5 just now, which will be 30 times 158 should be, let me see here, 158. It should be 4740. So I just put it as a 4.74. Yeah, 4.74. Sine of 2 pi times 10 power of 8 t minus 5 of x direction of y in volt per meter. Yeah, volt per meter. Okay, so what you have to do is that you have to differentiate this E field term. So we're going to have it as the JD will be equals to 5.69 multiplied with epsilon naught. And so when we differentiate this with regard to time, we're going to have 2 pi times 10 power of 8 shall be taken out. And subsequently, we're going to have it as 4.74. Okay, 4.74, and then it should be cosine. Yeah, cosine of 2 pi times 10 power of 8t minus 5 of x direction of y. So that should be your JD. Yeah, in the units of ampere per meter squared. Okay, so that should be your JD, basically. Yeah, so because we just based on differentiation of the dd over dt, if I can recall it back or repeat it back. So the dd over dt shall be epsilon of dE over dt. Epsilon will be 5.69 multiplied with epsilon naught, which is epsilon naught epsilon r here. Yeah, and then we have differentiation of the equation of E field with regard to time, and as such, that should be the results for your JD, which is your displacement current density. Okay, is that clear on the solutions for example number 6 here? Any questions so far? No, yeah? Okay, if there's no questions, I think we can proceed with the last questions for this example. Yeah, I believe that this is almost the same technique of solution to find the, to solve for these questions, because we are given the lossless dielectric with this following information. The mu is mu naught, epsilon is 3.4 epsilon naught, and the E field, now given the E field to be 10 sine 3 times 3 pi times 10 power of 8t minus beta z direction of x. Okay, so from this equation, I think there are few informations that we can extract. Yeah, we have the field or the E field is said to be propagate. Yeah, is said to be propagating in the z direction. Yeah, z direction is the direction of propagation. The E field polarized in the x direction. Yeah, polarized in the x direction. And the E field amplitude is equals to 10 based on the equations here, whereas the omega equals to 3 pi times 10 power of 8. Yeah, so the phase constant is given to be beta here. Yeah, sure, beta is your phase constant. Okay, so based on this, with the followings need to be obtained. The first one is the amplitude. The Ex positive is the amplitude of the E field. So basically, this will be 10 straight away. So 10 volt per meter. Yeah, based on the given equations here. So E will be 10, the amplitude. The frequency will be 10 power of 8. Sorry, not 10 power of 8. Sorry, my mistake here. Not 10 power of 8. Yeah, because that should be based on f, because we know that omega is 3 times 10 power of 8. Yeah, omega is 3 pi times 10 power of 8. So that should be equals to 2 pi of f. And from here, we can see that the f value shall be equals to 1.5. Yeah, 1.5 times 10 power of 8, basically. So f will be 1.5 times 10 power of 8. Yeah, so that should be your frequency in hertz. Yeah, in hertz. Okay. Is that clear on this? Any questions so far? No, yeah? Okay, how about the beta? Okay, the beta should be based on the equations of omega set of mu epsilon. Yeah, because this is related to the lossless dielectric. Okay, so omega is 3 pi times 10 power of 8. Mu is given to be mu naught only, which is 4 pi times 10 power of negative 7. Okay, and your epsilon will be 3.4, okay, times 8.854, yeah, which is the epsilon value. Okay, so I need your help to calculate this, yeah. So hopefully you can calculate this for me on this value of beta, yeah. Okay, so I'll have this for you to calculate this on your own, yeah. Because this is just based on the values that's given. So just by using a calculator, you will be able to find the beta value. Okay, how about the mu? Okay, the mu is your, sorry, not the mu, the u velocity. So this is the velocity of the wave, and that should be based on 1 over third of mu epsilon. And we're going to have it as 1 over third of mu naught multiplied with epsilon naught, yeah, and this will be multiplied with 1 over mu r epsilon r. Okay, and from here we can have it as 1 over third of 3.4. Yeah, this is epsilon r, whereas epsilon r, this is mu, this is epsilon r value, whereas for the mu r equals to 1 and multiply with 3 times 10 power of 8, yeah, because this is equals to 3 times 10 power of 8, the velocity in the free space. And basically from here, by using calculator, simple calculation, we're going to have it as okay, it's about 1.62, yeah, 1.62 times 10 power of 8 meter per second. So that should be your velocity of your wave in the given dielectric. Yeah, and for the impedance, the intrinsic impedance, the eta, that should be based on set of mu over epsilon, which is a set of mu r over epsilon r multiplied with 377, and we're going to have it as mu r equals to 1, epsilon r equals to 3.4 multiplied with 377. So what should be the value? We're going to have it as 204, yeah. So the impedance for this given dielectric is 204 in ohm unit, yeah. So that should be your impedance for the given dielectrics with the following properties, yeah. Okay, and finally, and then you have to find the Hy positive, which is the amplitude basically, yeah. This is the amplitude of the H field, and this is based on relationship that the impedance shall be equals to the amplitude of the E field over the H field amplitude, yeah. And from here we can see that the H field amplitude shall be equals to, yeah, shall be equals to the amplitude of the E field divided by the eta, and we're going to have it as a 10 divided by the eta, which is 204. And for this, the H field will be equals to 0.049, yeah? 0.049 ampere per meter. Okay, so that should be the amplitude of your H field, yeah? Right, and then for the lambda, yeah, lambda is the wavelength, the wavelength of the wave, so that should be based on lambda will be equals to the velocity divided by the frequency. So the velocity that we have calculated from part D just now, yeah, 1.62 times 10 power of 8, so we're going to have it as 1.62 times 10 power of 8 divided by the frequency, which is 1.5 times 10 power of 8. Okay, so that will be 1.62 divided by 1.5. So please calculate the lambda based on this ratio of 1.62 and 1.5. Okay, so basically these are the things that we have calculated, the parameters that have been calculated based on the given information of the properties of the loss dielectric, and also based on the given electric field wave equations.